Here we have question about submersible systems, and he's asking for that why we need steel walls of almost 12 centimeter thickness. Look, when you are preparing and when you're developing any submersible which need to move in the water in the deepest part of the oceans, there is an enormous pressure which it's supposed to bear, because the water is very high density, and when you move in the depth, you need to endure that pressure. So if the steel walls of the submarine is not that much good, it can't withstand with the crushing force of higher water pressure, and it collapses. So that's why we need them. A diver will experience twice atmospheric pressure by descending just 10 meter below, and you need to climb over 5,000 meter to half the sea pressure, air pressure. So, first of all, the very major reason of this phenomena is that the density of water is much higher as compared to air. So that is why if you just move 10 meter below, you feel that pressure because mass per unit volume is more. But if you move above in the air, air is not much denser. So you need to move 5,000 meter above just to feel that air pressure release or air pressure halved. Then we have what are the two forces affect you float? That is weight, downward direction, upthrust in the upward direction. And how do these two forces compare in size? If they are floating, is equal to balance forces. If they are balance forces, you can float. If upthrust is higher, you rise. If weight is higher than upthrust, then you sink. Then we have the next question. A boy's weight is 500 Newton. What upthrust does he need to float? As we earlier said that floating is equal to balance forces, so 500 Newton weight, so 500 Newton forces upthrust required. Hot air balloon is floating in the air and it gives upthrust. What are the two forces? They are the same like weight and upthrust. And what about these forces? The two forces are equal in size. Upthrust is equal to weight. If upthrust pushes up, weight pulls down. If they are equal, then the balloon float. Otherwise, it rise or sink. Describe how you can measure the upthrust on an object. You just need a Newton meter or force meter and hang the object with it, measure its value, and then calculate the weight in the water. First in the air, and then you can just use any of the bathtub and place your object on it and just hang it with the force meter so you can feel the difference, and you need to determine the value, subtract the value, and you will get the upthrust value. How could you find out if the size of the upthrust depends on the material the object is made from? You can do the same experiment, calculate the value in air and then in water, but you will measure that thing that upthrust does not depend on the material, it depends on the volume of water displaced, because that volume of water which is displaced apply upward pressure on the object and it floats. Explain why whether a tube of iron will float in mercury. Yes, it floats because iron density is less than mercury, and you can see it very clearly here. Then explain why polystyrene will float in water but not in air. You can compare the values. Polystyrene density is less than water, so it floats, and it is more than air, so that it doesn't float. Steel is denser than water, so how you can steel ship float? Look, steel is it's a properly hollow shaped, big size object. It's not a solid block, so it displaces a large amount of water, which applies upward pressure on it. That's why it floats. Explain why making the air inside the balloon hotter makes the balloon rise, because it is low density, so it moves in upward direction. So just why pilots need to study meteorology and navigation. Um, Pilots need because they they need to overcome the weather effects during flying conditions. They need to move the plane with the safe flight routes, takeoff and landing safety, and they also need about navigation to follow the correct flight path to avoid any restriction or dangerous airspace, to use instrument and map accurately. You can observe there are a lot of happenings in the past as well, when there is also one of the incident in which two aeroplanes collide head on, and they're having head on collisions in the air, and there is a complete loss of all the life. So a pilot doesn't have that much ability to navigate and meteorological studies, so it's a huge risk. So just why two pilots of Boeing 737 would have to do more training before flying an Airbus. Airbus and Boeing 737, they are two different systems. So there is a difference in cockpit control layout, there's a different flight control system, emergency procedure, checkout list, and regulatory equipment. So if you are not a pilot of particular systems, you need to go through all of the things. So just why air traffic controllers need to study meteorology, because weather effects flight safely, to manage air traffic flow, to give pilots accurate weather update, to coordinate emergency responses in severe weather, and to make sure that the passengers reach their destinations safely. Why do maps of pilot show things like radio maps? Maps for pilot called aeronautical charts. They include the features like radio maps because safety, to avoid collision, navigation awareness, and flight planning. Maps show radio maps to help pilots, especially at lower altitudes or in bad weather. Explain why the wheels are moved inside the aeroplane after takeoff, to reduce air resistance, to improve fuel efficiency, to fly smoothly and safely, and to protect the landing gear. Airlines fly at a height of about 12 kilometers. Explain why they must have pressurized cabins and breathing masks. At 12 kilometer, air pressure is too low to support your normal breathing, and without pressurization, passengers and crew they suffer from hypoxia, which is a lack of oxygen, and it might lead to unconsciousness or even death. So their cabins are having that oxygen supply. And if they depressurize and due to any of the reason, they have their oxygen levels drop. So they have their oxygen masks, their emergency masks, which supply their supplementary oxygen to them. Okay, we have as the balloon went up through the atmosphere, it got bigger. Explain why this happens. Using Okay, when you are moving to the higher altitudes, there are fewer particles on the outer atmosphere, the outer atmosphere. So less pressure outside, so more pressure inside. So that's why they expanded. Sketch a graph showing how the temperature changes with time when a piece of ice is left. So that is a starting point at 0 degrees centigrade. It absorbs heat. It is moving in the upward direction. By absorbing heat, you have a slope. And when ice start melting, you have a straight line. And that is showing the melting phenomena. And when all of the solid melts and converted into liquid, it start again the temperature rising. And when your liquid, all of the material is converted into liquid and get converted into and start converting into gaseous phase, there is again a phase change. A straight line will be given, and you will get that graph. Why ice floating on liquid water is unusual? It is unusual because usually solid has more density than liquids, but has less density because of the particle arrangement, because of the particular arrangement. There's spaces between them, so less mass per unit volume, and that's why that has that type of floating phenomena or less density phenomena.